Eric Darling here with Darling Data, the darlingest data there ever will be. And in today's video, we're going to talk a little about, because I like doing those little about videos. We're going to talk a little bit about SOS scheduler yield. Fresh back from vacation, tan, rested, ready, haircut in full effect, feeling good. I tried to record this video a number of times and just been sabotaged by various things that were really too annoying to go into detail on. So we're going to skip that. And we're just going to talk about our good friend SOS Scheduler, because I think it's an interesting weight. Right? It can be a pretty decent indicator that your server is under CPU pressure if SOS Scheduler, and like there are a number of like correlating factors in there, but like if SOS Scheduler yield is constantly way at the top of your wait stats and the total number of hours of SOS Scheduler yield is always like at or near your server's uptime, or even over your server, especially over your server's uptime, it can be a pretty good sign that your query's under CPU pressure, because what SOS Scheduler yield sort of indicates is that queries are waiting for CPU attention. And the more time queries spend waiting to get CPU attention, the less time that means that they're actually like running and like being productive little queries. What SOS Scheduler yield basically means is that your query is ready to go. Right? It's ready to run, it's ready to rumble. I didn't say the whole line, so Michael Buffer can't sue me. But like your query is good to go. It's not waiting on like reads, writes, locks, pages, memory, disk, anything else, CX stuff. It's just waiting for a CPU to say, "Come on, come exhaust your quantum with me, and we'll have a grand old time together." So the four main states that your query can be in. There's running, which just means your query is on a CPU doing stuff. It's active. It's going, right? Runnable is when you see SOS Scheduler yield weights. Suspended is basically any non-SOS Scheduler yield weight, like any other weight type you see is going to show a suspended status, right? If you're SOS Scheduler yield, you run a bull, you're not waiting on any other resources. Any other resource weight, your query will show as suspended while you go get, like, you're not allowed to get near a CPU until you have all the stuff you need. And then there's sleeping, which means your query is finished and you should probably close some connections, fix connection pooling, whatever you did to make your query go to sleep and not close things out, hold locks and block a whole bunch of people, and that whole thing. Anyway, SOS Scheduler yield weight. I usually like to explain this as like you going into a bar and trying to order a drink. Now, you got this sort of list of points up here, and one thing that I want to point out about this list of points, about the points, is that it has been a real long time since I've been carded for anything. I started drinking in bars in my early teens because my voice changed early. I basically had the same voice since like 1993. I started being able to grow sideburns really young, and I started smoking cigarettes really young. So I quit, obviously, because responsible thing to do. But when you're a 13-year-old with a deep voice and sideburns, you walk into a bar and you smack down a pack of cigarettes and a Zippo. You just order like whatever cheap American domestic beer. No one really questioned you, right? Just kind of act like a jerk. Bartender's like, well, he's been here before. So some advice for the young kids out there, all the youths who watch my SQL Server video. But it's sort of like, you are the query. You walk into a bar, the bartender is a CPU. Your job is to have everything you need to get that bartender's attention and say, this is what I want, and have the bartender start working on it. So various things might get in the way. Needing an ID, needing money, bouncers, or a long line of patrons who are also trying to get to the bartender to get their attention, to get them to make their drinks, right? And the last thing you want is a bunch of drunk people waiting a long time for drinks. That's a recipe for a fight. Right? Cutting in line, elbowing, bad scene. So one thing about SOS Scheduler yield is it's always going to have high signal wait time because it is a CPU signal. It is your query waiting for the CPU to say, "Yep, come on over, do your quantum dance with me, and you and me will get these results out to SSMS faster." Who would return results anywhere? Export to Excel, I guess. Dump it into an Excel file like everyone else does. So when you have a lot of queries running and not enough CPUs to service them all, you may end up with really long lines of queries waiting to get CPU attention, which is when you'll see SOS scheduler yield weights really spike up, which is when your server might be under a lot of CPU pressure. Some interesting things that I find slow queries down and also keep CPUs very busy are things that have like sort of like frequent executions, right? Like scalar UDFs, they don't, at least when they're not inlineable, they get called once per row that they have to process. Cursors, loops, stuff like that. Those things will generally keep CPUs very busy and interfere with like query processing stuff. Just keep the lines really long. Could be annoying. One thing that you don't want to do in response to, well, actually, I should step back a little bit. So one thing that you might also see if SOS scheduler yield weights like really get high is not like, casual drug use high. I mean like time high, get high on time. One thing that you might see eventually is as these lines grow is you might start hitting thread pool weights, and thread pool means that you've run out of worker threads. And some people have the tendency to throw a whole bunch to manually increase the number of worker threads that SQL Server creates, or is willing to create as queries execute. And what you're going to find then is that SOS scheduler yield weights are going to get driven even higher because you're going to have way more worker threads vying for CPU attention. So that's usually not a good response to thread pool and high SOS scheduler yield weights, because it's the analogy I always use. It's like adding like thousands of screaming kids to a classroom without adding more teachers to help the screaming kids. It's a bad idea. So what we're going to look at is sort of how SOS scheduler yield weights accumulate in a vacuum, and then we're going to look at how they accumulate when we have a bunch of queries lined up waiting for them. Now, for the initial stuff, we're going to be using my normal demo server, SQL Server 2022. It's about 100 gigs of memory. It's 16 CPUs on my fabulous new Lenovo laptop workstation beast. And then we're going to use a much smaller VM called server tuning. And server tuning, I didn't want to connect. I'm sorry. It's not what I actually wanted. Go away. I just wanted to look at the settings. Server tuning is a much more modest VM. It only has about 14 gigs of memory and 2 CPUs. So what we're going to look at is when we throw a whole bunch of single-threaded queries at that and look at how SQL Server sort of manages them. So we're going to stick this into a new window. And this store procedure, well, this is just temporary store procedure. I actually have to switch this out. I'm not sure what happened. I installed, like, this used to run for about 10 seconds with the old number, but I like installed a bunch of like system updates and stuff, and all of a sudden, all of my it takes way more iterations for that to get up to 10 seconds of execution time. So I don't know what happened, but it happened, and apparently there was like some like CPU fix in there that made them faster or something. I don't know. Maybe Windows 11 just got better at dealing with the P-core and E-core thing. I genuinely don't know. But what this is going to do is sort of like the effect of like if you have a scalar UDF or if you have a loop or a cursor or something, where we're just going to like bzzz, like attack, like swarm of gnats, stinging the crap out of you, biting your butt. And what we're going to do is dump some wait stat data about SOS schedule yield into a temp table, run the procedure, and then diff it. The reason why I use store procedures, but temporary store procedures here, for this is to avoid async network I/O waits. It can get annoying. So let's run this whole thing. And this should take about 10 seconds. If I lift up the right arm, we'll see the time ticking away right about here. And 11, close enough. So in 11 seconds of just incrementing this up, we have about 2,700 waits on SOS scheduler yield, and only about 3 milliseconds of total wait time on it. Two of those 3 seconds, probably because of some rounding stuff, were on signal wait. So that's kind of what I was talking about. SOS scheduler yield always going to be on the high side of signal waits. But what's interesting to me, I think, here is how much work we're able to get done in this loop while it's executing before like we hit like an SOS schedule yield. So this is actually a very productive loop, right? It's like we get a lot of like iterations done before the query's like, okay, step off, am I good? Right back on, right? So cool, right? Good stuff there. Now let's look at when we have just one big slow. This should also run for about 10 seconds. I had to make some adjustments to this one too to have it run for 10 seconds because apparently, my CPUs just got awesome overnight. So we're going to do the same thing here. We're going to run this big query that just does a bunch of cross joins to a tiny table with a few extra union alls. We're going to make it run at max stop 1, and then we're just going to get a max of all this stuff. So let's just kick this whole thing off. And this should also run for about 10 seconds, right about here. 8, 9, 10. Oh, 10 on the nose. So this one here, just about the same number of waiting tasks in that time on, or waiting, like waits on SOS schedule yield, and also just about the same wait time and signal wait time, right? Cool. So single-threaded query running for 10 seconds, completely unfettered by anything else doing anything. There's nothing else is using CPU on this on my home laptop. Generally racks up a small amount of SOS scheduler yield because we're just often right back on, right? We're not like waiting in a big long line to get back on, to get CPU attention, to get back on a CPU to run. So single threaded, right? Let's do this same thing, except oh wait, we're in the wrong tab there. Sorry about that. Let's do the same thing, except we're going to run this at DOP8. And this is just to show you that parallel queries, because we have multiple CPUs engaged, and we're scheduling DOP worker threads, they're going to rack up a whole lot more waits on SOS scheduler yield. And that's really the point of this thing. So we're going to do all this. This should also run for just about 10 seconds. You can 8, 10 on the nose. Look at that. Amazingly timed query. So what do we end up with? Well, we end up with a lot more waiting tasks, right? We have 20,000 there rather than like 2,300, 2,400 with the single-threaded query. And we also have a lot more wait time. And of course, because we have more wait time, we have a lot more signal wait time waiting to get CPU attention. So all those parallel queries will drive up both the number of waits on SOS scheduler yield, because we have DOP threads able to like get scheduled on CPUs, and they all have to hop on, hop off, hop on, hop off, do their thing. Yeah, that's about that there. Right? So parallel queries are going to necessarily drive up SOS scheduler yield because they have more active requests on CPUs, and those active requests all have to get co-scheduled. So you have DOP threads getting on for 4 milliseconds, about, exhausting the quantum, stepping off, stepping back on, and depending on how lucky you are, making like hopefully all your parallel threads end up in different places, and you're not trying to like co-schedule stuff around. That would be fortunate, but yeah, that's parallel queries. You're going to see more SOS scheduler yield waits. Now, what we're going to do is we're going to well, I already have that done actually. We're going to use SQL Query Stress by the lovely and talented Eric EJ on Twitter and GitHub and everywhere else. He took over maintaining SQL Query Stress when Adam Mechanic said, "I've had enough of you SQL Server people. I'm going to go use Postgres like a normal human being." And yeah, so Eric EJ, thank you for all you do. So I have this query already in SQL Query Stress, and I have this window with SP who is active, ready to go. I've sort of trimmed down the column list so we can just get to the stuff that I really want to show you. But if I run this, and this is running at DOP1, and I keep hammering away on who is active. Because this server only has 2 CPUs assigned to it, what we're going to see is usually there's going to be 2 requests active, right? So these 2 are running, these are doing stuff, and the rest of these are runnable, right? So they're like ready to go. They have everything they need to execute, but they just don't have CPU attention. And if we run this a bunch of times, sometimes there will be 1, sometimes there will be 2, but in general, what we're going to see is the same pattern where a bunch of queries are like, please give me CPU, please, I need it. Why are you making me wait for CPU? And 1 or 2 queries just actively able to use CPU. Now, some of this does depend on timing and query placement on CPUs. Like when there was only 1 active in there, it was probably just very, very bad luck with like where SQL Server chose to throw one of those queries. I can kill this off. I think I've pretty much exhausted the point on that. But this is when you see lots of queries that are runnable, right? Like this. Like if you have constantly have like a long list of queries running, and most of that long list is runnable, and very few things are actually executing, it's a good sign that there's some pretty serious CPU pressure, at least in that moment on your server. You can correlate that to to very high SOS schedule yield weights to figure out if it's something that constantly happens, or if it's just something that happens once in a while when like things really heat up and you have like a really busy time on the server. So you can look at SOS scheduler yield weights in general. I prefer SP pressure detector. I forget what, something's weird there. But if you run this and we look at the weight stats, I think I updated it recently to fix an issue. But if you look at weight stats, well, if there's SOS scheduler yield. Despite my fantastic demos, it is not very high on the list. This server has been up for a while, but I just haven't been doing much to it. We have no hours of wait time, but what can you do? I suppose if I really wanted to burn my CPUs out, I could do that, but I'd like this to last a little while. I'm not in a rush to spend another like $5,000 on a laptop because I burned the CPUs out after a few months. So if anyone out there has like lots and lots of Azure credits they want to donate to me, I'd be happy to show you what CPU burnout looks like on Microsoft servers. So when you have very high, so let's say you're in a situation where you constantly just have high SOS schedule yield weights, or when you hit your busiest times on the server, you have very high SOS schedule yield weights. You have lots of queries that are runnable but not running. They can't get CPU attention. The options that I would generally prescribe, well, getting faster CPUs is kind of tricky. Most folks are in the cloud or on a VM where you can't really pick and choose that stuff. Back in the good old days when you get to build your own servers, you could be like a real gamer type and get like a lot of really fast cores. So you could have like 3, 4, 5 gigahertz cores rather than like the older generation like 1 to 2 point something gigahertz cores. That could help like queries get faster, like do more work within the time that they got on a CPU. You could also just get more CPUs when expand the number of CPUs available to work on queries. Because the more of those you have, the less time queries are going to be spent. Less time queries are going to spend vying for CPU attention in the crowd, waving 20s and 50s and 100s, trying to get the bartender to make them a drink. You could also make sure that you have your various settings are in the right place. Parallelism settings can help with SOS schedule yield weights. Turning max stop down can sometimes help with that because you'll have fewer parallel threads spinning and trying to get CPU attention. Turning cost threshold for parallelism up can sometimes help because then you have fewer queries that are eligible for parallelism. It's not always a great fix because you just like long-running serial queries are just gonna it's unpleasant, right? You can cause a lot of performance regressions changing those settings. Those are global settings. Your better bet would probably be to add hints to specific queries that are messing you up at those times. You could also do some good old-fashioned queried index tuning. Right? The faster queries can run naturally, the better off you are, the less CPU time they'll need. It's all good for you. It's all up. And again, stuff that stresses single CPUs, long-running serial queries, user-defined functions that can't be inlined, cursors, other types of loops. And another big one that came up, actually was something that we talked about with Joe Obish on the last episode of Bit Obscene, is scheduled tasks and jobs that all occur simultaneously. You have a bunch of jobs that run every hour or 10 minutes, but on the hour, you just end up busting your CPUs for no good reason. All right. Anyway, I have a dinner reservation. I've been talking for 20 minutes, parched, and I'm just happy to have finally gotten through this video without any sabotage. So, if you like the video, give it a thumbs up. If you like this sort of SQL Server content, subscribe to my channel. You'll get notifications when I post these videos. It's good for you. Strong teeth and healthy bones, they say. And as always, hope you enjoyed yourselves. I hope you learned something, and I hope that you'll keep watching. So, thank you for watching. You're a great person. Follow me for more tips about underage drinking. Or probably don't. Not a good idea. Don't let your kids watch this, unless you're cool with that. I don't know. Anyway, I'm gonna go now. Goodbye.